Alright folks, for our last video for week 2, we're going to work on data import. So while packages like NYC Flights 13 have excellent data for us to work and practice with, in reality we're going to be reading in our own data files that we collect online or download from other repositories. The tidyverse package that we work with is readr. readr is designed for rectangular data and delimited files, so CSVs are the really common one. About 95% of the files that I read in are CSVs. CSVs are comma-separated values, so essentially just every individual cell is separated by a comma. And when we use the read CSV function, R knows how to read it in so that we get the tabular format that we've been working with. The function's really easy. Just read CSV, and then you put the file name in quotes. You've seen me do this a few times in our previous lecture. So all I've done is just designated the data folder within my DAX 601 working directory. So mine will say data/filename.csv. CSVs aren't the only type of files that readr works with. It also can read in semicolon separated files, which is just a different version of a CSV, tab delimited files, and others. Haven is another package in the tidyverse that helps us read in data files from other statistical packages, so those from SAS, SPSS, and Stata. Generally, if there's a data type, there's a function like read_that data type to read it in. Excels are a little bit different. So for Excels, we use the read Excel package. This isn't explicitly with tidyverse, and we're going to use the read Excel function. In the read Excel function, there's a few arguments that I think are really important: path, sheet, range, and skip. So Excel files aren't designed with data analysis in mind, at least for reading it into R. Often they're designed so that they look nice for audience members, for readers, but we get a lot of garbage. So we get a lot of blank columns, a lot of rows that don't mean anything, and then we have this column label, single without children, that encompasses 3 different ones. So we have multiple levels of column names. We're going to go through this example, active duty marital example, that will walk through data import, transformation, and data tidying. In the meantime, I want to run through a quick example with just our regular lecture 2 script. So I'm going to have you look up read Excel, because that's the different one that's not in the tidyverse. Read Excel, like I said, path, sheet, range, and then call names, skip, those are some of your really important arguments. What we're going to do is read in a simple Excel sheet called Wild Birds. So I have it in my data folder. We can see that Wild Bird is in format XLSX, in contradiction to a lot of these other files that are mostly CSVs. If we just run the command read Excel, when we look at this, it's not quite right, because our column names don't represent what this data actually looks like. We get wet body weight and population size, and then our column names don't make sense. So in Excel rows, people often put in different information like citing where the data is coming from, or for example, this is a particular paper. But that's not going to work for our data analysis. So instead, we're going to use the skip argument. And what the skip argument does is it skips a row of data. So let's try just skipping 1. When we look at birds skipped, okay, now we're starting to cook. Our columns are the correct names. But let's also just make sure that our everything is right. And so what we can do is we can create our own names. Rather than having names like this, that like when we're calling them in our functions, we're going to have to use the backwards tick because there's a space, we can actually rename the columns ourselves. So what we can do is read Excel, give it the file path, skip 2, so also skip the name, and then supply our own. So here, I'm going to run that line. Let's look at this. We can also use the glimpse. And now we see, great, our columns are weight, population size, and they're both doubles. So let's look back at a bit more complicated of an example. And I'm not going to ask you all to read in a file of the level of the active duty marital example, but it's going to help us work through some of the steps that we've talked about in previous lectures. So here, like I said, there's a lot of stuff going on. We've got junk at the bottom, we've got junk at the top, we've got columns that are kind of all over the place. And so our steps for working with this file is to sort through the different grouping categories. So this file represents a pay grade type here, pay grade level also in this same column, marital status if one's a parent, so we've got single without children, single with children, joint service marriage, civilian marriage, and then gender. What we're going to need to do is skip a bunch of rows, remove our blank columns, and also filter out those total rows. Now the reason that we want to filter out the totals is because that data will be represented multiple times. If we keep the totals in, if we were to just sum this column or take the mean, it's going to be inaccurate because the data is counted twice. It's counted in the individual cells and also this total cell. So part of clean data and tidy data is also that we don't want to have anything that has totals in it. That's what we do with our functions like summarize. So we're going to open up a separate file here rather than working in the lecture script that's already at 253 lines. I just opened a new one for you. So here we have, let me open up in my example scripts, our active duty marital example. So you saw how ugly that was. It was very messy. I'm going to remove my hidden objects just so that we're clean for this example. I'm going to take a bunch of different steps. So here, I'm going to run through and create individual data frames for everything, and then I'm going to show you at the end how to do it all at once. So let's start with just reading it in. Just reading it in as a mess. What we see is a lot of NA values. We see column names that don't really make sense. We see a lot of numbers. This is really, really messy. It's not in the shape that we want it to be. So first what we're going to do is we're going to create our own column names. And what we're going to do for those that are blank, that we don't actually want to keep, is we're going to label them either delete, or you can use your own word. I like to just use delete because it makes the most sense for me. So we're labeling exactly which ones we don't want in our final version. And then what we're going to do is we're going to, every single column, we're going to condense those names. So remember how there were two rows, one would say married without children, and then the next would say male. What we're doing is we're instead saying single, no kids, and male. So we're collapsing all of those identifiers into just one, so that way the column title will make sense. We go through all of those, and then at the end there's 3 columns that I want to delete in a row, so I can use rep delete 3. That's just telling it repeat delete 3 times. So we're reading this in, and this is just a vector of character type. It's just 17 different strings that are just the names. And we don't want any columns that have the word total in them. So first what we're going to do is we're going to read in. So creating a new name. The first one was just messy to show you the example. Now we're going to start calling it marital DOD. Read Excel. Then I read in the file name. I'm telling it what sheet, because this is an Excel file with multiple sheets, multiple tabs, and so we have to tell it which one that we want. We're skipping 9 rows because that's how many are at the very top, including those column names that we've now collapsed into single ones. And we're assigning our own column names. So let's go ahead and look. This looks a lot better. So we've got delete, single, no kids, male, pay grade, pay level, right? We've reduced a lot of the NA values that we're seeing when we just read it in plain. We want to remove those blank columns. So the ones that have delete, we don't want them. And so we're just going to select anything that does not contain delete. And again, I'm naming this each step of the way. So now, okay, great. We've gone from 17 variables down to 9, and we don't see any of those empty ones that we deleted, that we wanted to be deleted. We also need to remove those total rows because those don't make any sense for us. I'm naming it filter because that's the step we're taking right now. So we're taking our previous data frame, our selected one, our most clean one yet. Then we're going to filter. We're using string detect. Now, string detect is a function that we're going to talk about in the next weeks, but I want you to know about it now for reading in Excel files. And so what it does is it detects if a string is present. And we're saying, hey, in this pay grade pay level column, anytime it says total, we don't want that row. Do not keep that in our filtering. So we'll see those totals are all in here in this pay grade pay level. So we run this, great, and let's check it out. We went from 30 observations of 9 variables down to 24. So we no longer have totals. We're starting to look pretty good. All of the values in here are numerical with the exception of this column. We're starting to cook. We also want to pivot longer so that we can separate those columns that represent marital status and kids and spouse and then gender. So what we want to do here is we're going to call it DoD longer. We're taking our most clean version, our last one at DoD filter. Then we're saying all of the columns but pay grade pay level because this doesn't have the same structure. It's not single, kid status, male, single, military, male, right, whatever. Or I should say marriage status, other gender, marriage status, other gender is the structure we're following. Our pay grade pay level doesn't do that, so we're saying select all the columns but this one. We're changing the names to marital, other, and gender. The separators are these underscores, and our values are going to be counts. So let's look at that. Now we've gone from 24 observations of 9 variables to 192 observations of only 5. So let's look at it. That looks a lot better. We have marital with the 2 different options, single or married, other, which is civilian marriage, kids or no kids, gender, and then the count of folks that fit that specific category of single, no kids male, single, no kids female, and etc. Now we want to split pay grade and pay level. So this still represents multiple things, pay grade and level. What we're going to do here is separate wider delim. We're going to say that the column we want to run this function on is pay grade pay level. The delimiter, so what separates one value from the next, is this dash. And then we want the new names to be pay grade and pay level. So let's run that. And what we get, great. Pay grade, pay level. Beautiful. So everything is pretty clean at this point. What we can do though is we can use case when. Because E, O, and W in this column here, it means nothing to me. I have no idea what that means. What we can do is update it so that E is now enlisted, O is officer, and W is warrant officer. The way this works is we're mutating, we're creating a new column, and then case when pay grade is equivalent to E, the new value is enlisted. That's exactly how I read that. And so you'll notice it's when the column name is equivalent to whatever the value is, use the tilde, and that says this is the new value. So go ahead, we're going to use that. And now at DoD mutate, we're looking pretty good. Pay grade makes sense, so enlisted officer, warrant officer, all of these mean one thing, and we're a world away from this mess that we started with. And this would have been impossible to run all of our different summary and descriptive statistics on. So that was a lot of steps to walk through. Let me show you how to do it all in one go. I don't expect you to be creating new data frames for every step. Again, that's just so that you can look at the differences. So if I were just doing this in a single go, here's how I do it. I create the column names, it's the exact same as it was above. We're going to call this DOD. Read Excel, great. We have our file path, our sheet. We skip 9. We say that we want those column names to be what we've created. Select anything that does not contain delete in the columns. Filter out anything that does, filter so that we only keep things that do not contain total in that pay grade, pay level column. We're pivoting so that we split up marital, other, and gender columns. We're separating pay grade and pay level so that way they represent different things. We're just splitting that column into 2. And then we're mutating using case when to adjust E, O, and W to make sense. So all in one swoop, here we go, DOD. Look at that, the exact same as DOD split, which was our final version. So here you see the whole process. We read in the file, and if it's a CSV, that's pretty easy. If it's an Excel, it's not so easy. We have to play with the rows and the columns and make sure that they all make sense. We've transformed our data. We've shifted it so that all the columns make sense in terms of naming. We've transformed the values within these cells so that they make sense. And we've also tidied it so that each of our columns represents only one thing and that each row represents one thing. So that's an example of the process of what we took 200 some lines to learn. You can do in 30 or less. This is a more complicated example than what I expect of you. So that's it. That's the end of week 2. Stay tuned for week 3.